Air pollution is one of the greatest threats to public health and the environment in the 21st century. Every year, millions of people suffer from respiratory and cardiovascular diseases due to air quality compromised by harmful substances. According to the World Health Organization, WHO, approximately 7 million deaths per year are attributable to exposure to air pollution. But what are the main causes of this problem? Emissions from industrial activities, vehicle traffic, agricultural practices, and domestic heating significantly contribute to the presence of toxic substances in the air, such as fine particulate matter, PM2.5 and PM10, nitrogen oxides, NOx, sulfur dioxide, SO2, and carbon monoxide, CO. These pollutants not only negatively affect human health, but also alter the climate, contributing to global warming and the formation of extreme weather events. In 2025, an international team of scientists made an extraordinary discovery, a protein capable of degrading major air pollutants and transforming them into harmless compounds. This breakthrough could mark a turning point in the fight against global pollution, offering a sustainable alternative to current filtering technologies and emission reduction strategies. It all started with the study of extremophile bacteria, organisms capable of surviving in extreme environments such as deep ocean trenches, volcanic calderas, and even the driest regions on Earth. Scientists discovered that some of these bacteria possess a metabolism that interacts with toxic gases, absorbing and transforming them into harmless compounds. After years of research, scientists isolated a unique protein, AtmosCleanase. This enzyme has demonstrated an exceptional ability to capture and transform nitrogen dioxide, carbon monoxide, and other pollutants, converting them into oxygen and water through a natural biochemical process. Its mechanism of action resembles photosynthesis, but instead of absorbing carbon dioxide, AtmosCleanase binds to pollutants and neutralizes them. Scientists are developing innovative methods to produce AtmosCleanase on a large scale and integrate it into existing air purification systems. The potential applications of this technology are numerous and revolutionary. Buildings covered with purifying biofilms, skyscrapers and urban infrastructure could be coated with biologically active surfaces capable of absorbing and transforming air pollutants. This would allow cities to actively combat pollution without requiring costly new infrastructure. Genetically modified trees. Integrating AtmosCleanase into plant DNA could enhance their ability to absorb harmful substances, turning urban parks into artificial lungs that significantly improve air quality. Advanced filtration systems. AtmosCleanase could be incorporated into air filters in indoor environments, cars, factories, and industrial plants to drastically reduce harmful emissions before they reach the atmosphere. Several countries have already invested billions to test this technology. China and the United States have announced urban trial projects with promising results. In Beijing, a study showed a 30% reduction in fine particulate matter within just a few days. If applied on a large scale, this innovation could even reverse the damage caused by decades of industrial pollution. In Europe, various research centers are studying the integration of AtmosCleanase into public transportation networks. Buses and trains could be equipped with devices based on this protein to actively contribute to air purification during their regular operation. Despite the excitement surrounding this discovery, challenges remain. Biosafety is a key issue. The long-term effects on ecosystems must be carefully studied before AtmosCleanase is deployed on a large scale. Additionally, producing this protein in sufficient quantities to cover entire cities presents logistical and technological challenges. Some laboratories are experimenting with integrating AtmosCleanase with catalytic nanoparticles to amplify its effectiveness. Preliminary simulations indicate that this combination could reduce air pollution by up to 50% in just 1 month. If we can develop bioreactors capable of mass-producing AtmosCleanase, we could implement it not only in metropolitan areas, but also in remote regions where pollution poses a severe threat to public health. Are we truly ready to embrace such a revolutionary solution? AtmosCleanase could forever change how we tackle air pollution, but it is crucial to proceed with caution and regulate its deployment to avoid unforeseen consequences for ecosystems. Science has given us a concrete hope. Now it is up to us to use it responsibly. If this type of content excites you, we invite you to take a small action that means a lot to us. Click like and subscribe to the channel. This helps us create more high-quality content for you. And don't forget to activate the notification bell to stay updated on the latest scientific discoveries. The universe is vast, but together we can explore and better understand the world around us. Thank you for being here with us.